Welcome back to Data Science at Home podcast. I'm Francesco, podcasting from the office of Ametix Technologies based in Brussels City, Belgium. Today, I'm not alone. I am with Sanjoy Chowdhury. I hope I pronounced it correctly. Hi, Sanjoy. How are you doing today?
Hi, thanks Francisco for having me. Yeah, I'm doing lovely. It's so nice to be here with you today, and yeah, I'm looking forward to the podcast. Yep.
Yeah, so basically, Sanjoy is a researcher at University of Maryland, College Park. And his background, of course, you can explain to us a lot better in a minute or less what you do. But essentially, he works with multimodal machine learning, which is one of the most interesting topics these days. For the folks who are not very familiar with multimodal machine learning, very very briefly, and of course, Sanjoy will give us a much more technical explanation of what that really is essentially combining multiple sources of different nature into one, let's say, conversation. But of course, it's not just about conversations; it's about prediction or reasoning, understanding the world, and so on. So, Sanjoy, please take the stage. I mean, what do you do as a background? What is your specialty?
Yeah, of course. So, yeah, as you said, I think very nicely summarized that I primarily work on multimodal learning. So, multimodal learning is a specialized form of AI where we work with all these different input signals. As a human being, we are very like from right after our birth, we are very much convenient dealing with all these different signals, like the visual signal, the audio signal. We can read, we can perceive, we can touch, we can sense. All these different things we can do very easily, and we grow as a human being. As we grow up, we develop to grasp all these different modalities of signal input signals. My work is to make machines aware of this. So how do we combine all these different systems, all these different input sensory signals, and then also make sure that models are safe in terms of how they are processing this. They can reason over this, and they can also understand and comprehend, as the case may be, like what the different sorts of tasks that we're interested in. So long story short, it's like a holistic understanding all these cross-modal signals. I am particularly excited about building more recently, like agentic AI system which can reason, act, and perceive across different modalities, and also interested in systems which are efficient and trustworthy and can be actually deployed for more user-facing interfaces or use cases. So yeah, in a nutshell, that's what my work is about.
That's great. But in fact, I would like to make one step back because, for making this conversation self contained as much as we can, because 30 minutes for such a complex topic is, of course, impossible.
Yeah.
But there is a problem here. And the problem is the following. If we take a single large language model or predictive model in general, and we, for example, make predictions about computer vision, so it's a visual model, or another one about text, so text based, or yet another one about, I don't know, physics simulation, so it's pretty much numeric model. These three things, isolated in a standalone fashion, they actually work pretty well, except the edge cases, but they do a decent job, and in many cases more than decent. Think about object recognition, for example, or describing a scene with visual models. These are things that I've tried some of them,
Mhm.
and they seem to do their job quite nicely. But still, when we let's say put them together and we expect one bigger model to, for example, do basic reasoning about different senses, let's say, that's when things go banana. So what's going wrong?
I think that's an excellent question. So, yeah, so the answer would probably the reason of failure of such models. I would not use the term failure because it looks very harsh. I would say the limitations would probably be due to the following reason. One of them, I would say, the context, because it's very difficult to model this context in contextual information that sort of spans more than one modality. So we, as I said, so human sense, as we develop right from our early age, we tend to understand all of this information very nicely and very coherently. So it's not something we understand the vision first, then we do the audio first, and blah blah blah. It doesn't happen that way. It's very natural and organic in a way that we learn to understand, not only to isolate but also reason over them. So modeling this exact thing into this AI model, it's supremely difficult, in a sense that they all this information, all these streams of inputs are temporally and semantically very much entangled. We cannot, as you said, I think in the first part of your question, that individually they are doing really well, but what if we could just use, like, pass the baton to maybe one modality to the other? So the visual part does its job, and then we pass it to the audio modality or maybe some other modality. It's I think that very assumption can be a bit limiting in some sense. So it has to be but the alignment has to be at the very beginning, at the initial level. So for that, a lot of work recently has been going on. People have been working on learning this shared embedding space. If I go back slightly a bit, maybe like few years, so multimodal learning basically these days are trying to integrate all these different signals. Like, so for example, if we talk about clip model, which came out, I think it's been a while now. So the overall idea was to build a more sort of richer grounding representation across, say, vision and text, if we just shorten our discussion to that. Or maybe more recently, like image bind kind of model, where basically wanted to learn a shared embedding space across all the different modalities, and then try to make some sense of alignment across them. Or even if I take one more step forward, maybe the diffusion models, or the flow based models, where people are trying to generate not only to question answer but also generate some of the modalities conditioned on the other input. So that's probably the area where people have been the challenges has been how to not just individually encode the modalities, but how do we make sure that all of them are in sync, or in parallel, and also they can sort of handshake and communicate with each other. So this has been the challenging aspect. I would say the challenges are multifold. First of all, definitely because today's day and age, many things are data driven. So we need to have like annotated high class data for the models to do really well. If we look at if I again refer back to the example that you said, so many of the progress in the computer vision domain, or maybe the audio domain, or maybe textual domain, is primarily because of the fact that we had very high quality, rich annotated data for some of the unimodal tasks. So for vision, as you said, object detection, segmentation, we have like very solid data sets and very well crafted data sets for that. But for multimodality, I think it's been a challenge because how to what extent we should focus on either of the modalities, and how do we combine all this information, requires a lot of and it includes a lot of subjective bias. So whenever we are
Right.
planning to get some like data, or maybe train a model, or maybe at least get a very high level pre-training model ready, we need to have that. So which is very difficult, in a sense that the data collection is difficult, and also the modeling aspect or the architectural aspect is also very difficult. So
So wait a
probably
second, because you're throwing a lot of content here, and we have to digest to make this understandable. So there are two, let's say, extremes here. The first is, having a separate AI system for, let's say, vision, audio, text, or whatever other type
Mhm,
of data.
mhm,
So one can naively say, no problem. Let's train them individually, and then let's put them together at some point. And you're
mhm.
saying that that's not gonna work because it's not just combining these things at the later stage. It doesn't work like that. Why? It's because, for example, you have observed that human beings, or more sophisticated biological brains,
Yes.
they learn multimodality from the very beginning of their lifetime. So a baby learns to see and hear and touch and all together, right? um,
Yes.
and when it gets older, he or she gets older, of course, so she or he learns also how to read and comprehend text, for example, with writing and reading books and stuff. So these are things that um, happen together, right? And that makes perfect sense. So my question to you is now: uh, can we just take these individual models and let's say retrain them from scratch in multimodality fashion. I don't know if I'm being too sci-fi or just it's not feasible. So what I'm saying is, like, if we have these models that we have trained on vision, audio, and text separately, and you are just saying that no, these are things that you have to learn since the very beginning. So why don't we just retrain what we have with the multimodality in place?
Right. Yeah, I can totally get well, like where you are coming from. I think some of the initial efforts has been in this direction, and we have already seen some interesting observations in this space. So people try to take the existing foundational model for maybe one specific task, or which is catering to a specific modality, and then take that to combine with other modalities as such, like some very good object detection model. We take that with some audio understanding model or audio captioning model and try to combine them together. The problem, as I said, if I may use the term, like we call it like early fusion, late fusion. So I'll very briefly like explain what that is for our listeners. So early fusion means we fuse all this information across different modalities at a very early stage, what I was referring to a while back. So when we actually, yeah, exactly. So when we are having all these different modalities, and we do not train individual models, we try to somehow combine this information at the ground level at the beginning, by means of maybe a weak supervision, strong supervision, whatever the case may be. And late fusion is what we are now referring to. So we are more saying that what if we first develop individual models, and then if we try to make some handshaking protocol where they share information across them. The problem with that is many of the information, specifically if we look at in general our surroundings and like the events that are happening. For example, I am talking to you right now, we are having this conversation, there is a dog barking somewhere. My attention suddenly goes there. I just take a look, and then I understand, okay, there is a distraction that is happening, but I should not be focusing on that audio, I should be focusing on this audio. So all these different event happens, which are very instantaneous, context dependent, and also very much depends on what the overall scenario is. So if we try to encode that differently, the problem that we first observe is the temporal encoding. So first, when I'm speaking to you, or when we are having this conversation, the dog barking, that event is also happening at the same time, but we should single out that, okay, that audio event at this specific time is not important, something else is important. So if we try to encode it as a separately, it will also encode this audio information, and then it will also encode the visual information, and then it will try to draw parallel across the two modalities, which will be very difficult for the model to understand. So where I'm trying to get at is, it's more suitable for this model to encode this information at the very beginning, or the initial or more rudimentary level, compared to when we have encoded or maybe embedded to a different n-dimensional space, and then we are trying to understand. So that gets more complicated for the model to understand, even more complicated when we are considering a system like, say, ChatGPT, which is primarily text, but imagine ChatGPT which understands video, audio, all of that. It gets fairly complicated for this setup to distinguish which thing to focus on at what point, at what temporal dimension, what thing is important spatially. So for our conversation, maybe our facial region and all these things are more important compared to maybe the background and stuff. So all these things are more difficult when we keep it to the last minute. So the earlier we fuse, earlier we try to make sense of these modalities, it's more important and easier for the system to digest all this different information. So I would say that's probably the reason where some of the models are struggling these days. So
Wow, no, that makes a lot of sense. Um, okay, so majority of the models that we deal with today, I mean, you mentioned ChatGPT, and of
yeah.
course, all the class of large language model, especially when we use them as a chatbot,
Hmm.
they are single modality, one modality models, right? Most of the time, right?
Yeah.
These are not multimodal. And so what happens there is, like, when they try to sell us a new feature about, hey, now ChatGPT can see and understand scenes and the audio and stuff like that. What's happening there? They're just enriching the context with the output of another modality, and they just bring it into the same context so that it can fake that it got some other information from, let's say, an image or from a piece of sound or whatever.
Yeah, I think what generally people are trying to do right now, like including some of our research, and in general what we are trying to do is, as I said, we are focusing primarily on the early fusion stage. We are trying to make sense of making sure that of course there will be limitation in terms of the compute, in terms of the data that we have, but we still are trying to figure out. So as a reason why what we are doing right now is we are training on some pre-training tasks which are more like which requires more high level coarse grained understanding compared to in the post training stage, or maybe in the fine tuning stage, where we basically tune the model on tasks which are fine grained. So what we are doing is we are taking this loosely labeled data, because getting finer annotated data, it's more complicated. Getting loosely annotated data, is relatively easier. So what we are doing is we are using this data to do a large scale pre-training, where the models generally have a good understanding across the two modalities. And now once that is established, the models are decently good in terms of understanding what's going on, what is it about. Then we are trying to design certain specific downstream tasks. So downstream tasks are specifically triggered towards solving a certain example, maybe spatiotemporal localization, or maybe segmentation, or maybe, I don't know, like detection kind of thing, or fact checking in some cases. So those are the second level of training that we generally say, like pre-training, post-training, and then we use that to more fine-tune the model, which is specifically triggered towards certain aspect. And the other thing that I wanted to mention over here is it's very use case specific and it's very personalized. For example, let's say I'm a biomedical practitioner. The kind of response that I will expect from a model, say like ChatGPT or any of the chatbots that we have, or this foundational models, are, it's very much, it requires a lot of domain specific knowledge. I would say I'm passing you an image of maybe a USG or something, where it requires us to understand very finer spatial understanding, where certain thing is it natural or it's not normal for the patient, things like that. So all of that requires very specific knowledge. So many of the efforts these days people are doing is on like alignment of the responses. They are working on making sure that these models are aware of what specific response the person is looking for. It's more like at the decoding level, a lot of work has been going on. People have been working on that. But on the downside, some of the recent works have also figured out that these models tend to reason or think a lot. Sometimes it's useful, sometimes it's not. So all these are, so there are a lot of open threads, I would say. We are still at a very early days of this specific area, but I'm encouraged by the fact that we are actually trying out different aspects, and in some cases we are hitting to a dead end. We know that okay, this is not working, we have to figure something else
Sure.
out. But overall, the space is going in a direction which I would
I
feel
see.
yeah,
So
very interested about.
this is the exploration phase still.
Yeah, yes,
Okay.
definitely.
Okay. Can you explain to us what early fusion means exactly, or sorry, shared embedding? That's the terminology you used before.
Mhm.
So, like in a multimodal training, what happens that you learn embeddings from the multiple sources, and then
Mhm.
you use them, or how does it work exactly?
Yeah, so what I would say is it's typically a case of, because if let's imagine this way. So let's say inside our brain we are gathering all this information. I'll try to draw parallels with how human being understand, and then try to translate it to the model. So how we understand is we gather all this information. We have all these sensory organs attached to our body, and we understand different things, and then we try to make sense out of them. Everything happens so instantaneously, we are not able to distinguish how things are happening, why things are happening inside it. It's like in a matter of seconds things happen. So the intuition is, for example, the word in text dog, the picture of a dog, and the sound of the dog barking, say the audio. So all these things are, for this system, for this AI model or anything that we are talking about right now, is nothing but a representation in the vector space. So
The
it's
same.
just basically a combination of numbers. Now the idea, the broader goal that we have as a multimodal AI practitioner, is to make sure that depending on the context that we have, they all these three different signals that I just that we just discussed about, it's just mapping to the same place, and they're somehow understanding everything within the realm of like certain coding. So even if the term dog, now if we are talking about what is a specific breed of dog, how they bark, that's also again
Yeah,
different. So if we try to granularize things, it's getting even more complex for these models to understand. But in general, broadly speaking, the intuition is to translate everything to the language of vectors, if I may
yeah.
use that term. So I think that's
Okay.
the overall intuition of.
That's great, because that's, now that I'm thinking, because these are things that you don't think of because they are so natural.
Yeah, exactly.
So, for example, I want to challenge all the listeners here, uh, with this. Like, if you read the text "dog," very likely you start picturing the image of a dog in your head,
Yes.
and probably you can even, that picture triggers some kind of memory of how the dog, or dog, a general dog, barks in general. And the other way around, like, if you see a dog, I'm not saying that you picture it in text, but your brain, I think, it's prepared to translate that image of the dog that you're seeing with your eyes into something that you probably would see written, or you can kind of recollect the barking of the dog, even though the dog is not barking at all, because you are used to the concept of the dog. So a dog has a concept, and that's probably the closest I can get to the embedding, the shared embedding, probably.
Yes, I think that's a very good explanation. Yes.
Okay, that's great, man. This is like amazing research. I mean, this is wow. Okay, this is very fascinating. That very fascinating. Um, Sanjay, I have one question more on this. Like,
Yeah.
uh, probably you want to speak about the benchmarks of what you can share, of course, of your research. But the question that I want you to use as a driver for this answer is reasoning. Everybody these days is. There is a lot of hype. We know. We're
Yeah.
gonna touch on that at the end of this episode. But everyone is, believes that these machines can reason. Now, my question to you is: this is not happening, of course, with text, but can this work with multimodal machine learning?
You mean reasoning?
Yes.
Yeah. Okay. So the answer is both yes and no, because it depends on like how we are defining reasoning. I think it's the term is being used very widely, very vaguely in all the different contexts. So I would say we have seen some evidences, let's say, of these models doing decent reasoning for again, it depends on the kind of tasks that we are talking about. If you are talking about maybe some simple question answering tasks that requires the model to reason over maybe certain information which is present in the visual scene, and which is kind of directly derivable from what we are observing from the scene, in that cases, yes. But if things get slightly more complicated, then it's get very challenging. So let me try to explain with an example maybe. So let's say yeah, so let's say maybe spatial reasoning, if we say. So for example, me and you, we are sitting in a room. I am wearing a red t-shirt, you are wearing a black t-shirt, and then we are asking, say, which person is sitting to the right, or what is the color of the person who is sitting to the right. So that is also a level of reasoning, because the model has to first figure out who is to the right, and then understand at the clothes, and then understand this is red, black, blah blah, whatever. So this is still a simpler mode of reasoning. It also requires reasoning, but it's a simpler mode of reasoning that the model are still able to do that, I would say, at this point. But what if we make it more complex? For example, I have maybe we are playing, maybe I'm playing violin, and then the question is, what is the person, like which country does the instrument originate from, where the person is actually sitting to the left or right. So it basically requires two three different levels of understanding. So first we have to figure out who is sitting to the left, which instrument is that person playing, then understanding the instrument, then going back to the origin country of that instrument. So this requires three four different steps of reasoning. So in these cases, I feel or at least the experimental evidences that we are observing, that the models are not doing well. So this is probably because of the fact that these models are not trained to think this way. These are the models are generally trained with a very high level like data or samples where we have like direct class levels questions, and the model just tend to associate certain words or placements of certain words to certain answers. So that's probably the reason. But reasoning requires more finer understanding. We not only have to like solve the bigger problem, but also we have to solve a lot of sub problems. So first spatially localize, then understand the person, then understand the instrument, then go back to the country of origin and all that, all these different things which are very like easy for us as human beings, as we can like very easily process all this information. But at least from our recent efforts and experience, we are observing that these models are not doing well in terms of breaking down the problem. I would say the main issue is breaking down the problem into smaller sub steps. So in one of our works, what we did was we actually broke down the solutions into simpler steps. So if this is the question that I just talked about, if I break the problem into step 1, step 2, step 3, step 4, and then pass these prompts to the model, we are seeing that the models are actually doing well. I mean, doing well compared to what it was doing in a zero shot, like initially what its response was. So I think a lot of the effort recently has been to make sure, in order to understand how good the reasoning of these models are, we actually have to make sure that we either prompt or maybe use some sophisticated mechanism of injecting this information into the system as to how to break down a bigger problem. So it cannot be answered in one go. It has to go through certain process, information distillation across one question to the other, and then we have to come up to the final response. So that's the, I would say, my observation has been in the reasoning part. To answer your question, yes, definitely it's possible, but again, we are at a very early stage, specifically for multimodal reasoning. It's a fairly complicated task, as we can imagine, and it's very early stage these days. So
Nice.
yeah.
Okay. Well, we have time. Take your time, no rush. I mean, we don't have Sam Altman pushing for the next GPT-6 or whatever, whatever is the version we are at now. Yeah, I think 6. It's gonna be 6.
Yeah.
Okay, so jokes apart, I want to switch gear on something that is even
Mhm.
more, critical, which
Yeah.
is security.
Mhm.
Adversarial attacks. Long story short,
Mhm.
so we know that these models can be, we have had examples of adversarial attacks in the past,
Mhm.
especially with the computer vision models. These little patches that you could put on your T-shirt and fool the camera, not the camera, the actual computer vision system completely. There are cases of, to prevent face recognition, and people wear crazy T-shirts that fool the computer vision system and stuff like that. Now, uh, there are, of course, malicious intentions, and of course, non-malicious intentions, of course. My question to you is, again, in the picture of multimodality, how should we be looking at adversarial attacks? Are they more robust models? Are they still affected by similar types of attacks? What's the state of the art?
Oh yes, I would say robustness is a big issue. In one word, it's a big issue. So in one of our recent efforts, we specifically tried to address that. So our objective was to understand how good these models are when they are exposed to adversarial attack. So by adversarial attack, I mean we can, as you say, very easily we can just tinker with. So in an MCQ setup, maybe option A, B, C, D, we are just playing around with the different options that we have. So if I see there are two-person maybe playing guitar, I'm in one of the options, I do not list two, so I say 3, 4, 5, 6, something like that. So we as human being will be very quick to spot it out, right? We should be saying that, okay, I see only two instrument players and none of the option matches. But these models tend to operate as a yes man in some cases. So they are very like over affirmative response, so they always try to choose between something that is available to them. So the out of the box thinking is something that these models are not very good at. So if you give them 3, 4, 5, 6, it will probably choose say 3 or 4 or 5 or 6, any of the options. So that's probably an area. So coming to adversarial attack, yes, there can be different modes of adversarial attack. A recent paper came out which does even more fascinating. So for in an image of a dog, they write the word cat in the text. They write the word cat, and then everything else is dog. So it's dog, and there's the audio of a dog being passed. But now the question is, which animal do you see? And
Yeah.
guess what the response of the model was. It said cat, just
Interesting.
because there was this word cat written in the image, in text. So it's very fascinating how these models tend to think in some cases. Like, we still feel that we are yet to reach the bottom. But yes, adversarial attacks has been an area where a lot of work is going on. We are trying to understand why this is happening, like why definitely these models are not very robust to adversarial attacks, but there are some instances where people are trying to understand the maybe the watermarking, or maybe the underlying reasoning why it is thinking, so then try to debias some of the cases, because in most cases this thing come from a lot of bias in the training data. And so we have to somehow understand. So people working on in like unlearning, debiasing, these are some of the, I know these are like very high level terms I'm throwing, but just to give a context, this is something that people are doing to make sure that people are actually solving some of the tasks, adversarial tasks. The another important aspect that I wanted to cover in this area is compositional understanding. So for example, if we say the dog is barking and the bell is ringing, instead if we say the dog is ringing and the bell is barking, it makes no sense, it's absolutely nonsense. But if we pass on this as an option to the model, it will most likely, it will say yes, it's a meaningful sentence. So this attribute binding, like what is associated with what, dog associated with barking, bell associated with ringing, these understandings are also something that are like very much missing from the model. So they act as a bag of word model. So they consider, okay, I see all the words, I don't care what the order is, it's all jumbled up, I'll say this is correct. So this is something that again it's very concerning a bit, and
Yeah.
also bothering, I would say. It'll probably, as I said, it's very early days in the adversarial attack space, or in general robustness
For
space.
sure.
So it'll probably take a while for us to get to there, and then as a community, hopefully, yeah, we should be there in some time. So yeah.
No, I was thinking in preparation of this episode, of course, I was even, trying to understand potential solutions to, I mean,
Mhm.
I've been a researcher myself some years back.
Yeah.
Then I quit. I moved somewhere else, but I still do some, applied research on that. I was thinking on a personal level, maybe I'm giving ideas here. That's not a problem. Just cite me. Uh, uh, some kind of attention mechanism over senses. So imagine this: like when I see something, I don't need to hear. At some point, I can, but
Mhm.
and I cannot avoid, of course, because if there is a sound in the air, I will capture it. But for the reasoning process, that stream of data, let's say that sound, that audio channel, my brain could kind of consider it redundant or ignore it, even though it's there. Why? Because the let's say the sight of the scene carries enough information for which my brain pays more attention to the visual signal rather than the audio signal. Or some other cases, for example, where okay, there is this the touch. No, you can touch something and
Yeah.
your brain starts visualizing even though you don't see, right? Because you feel. So we have embodiment, of course. Machine learning doesn't have that yet, but
Yeah.
what I'm trying to say is, like, could there be some kind of attention mechanism on top of this multimodality that might probably, I don't know, I'm just, this is like pure assumptions, reduce the problem or increase robustness? Because indeed, if you have something somewhere written cat, and
Mhm.
you're not paying attention to that inconsistent signal, well,
Mhm.
then you're not gonna break the model, or you're not gonna break the reasoning. That's what I mean.
Yeah, I think what you said makes sense. There indeed are architectural advancements where we are using this. Of course, there is some sense of attention across different modalities. Otherwise, wouldn't have understood the very basics, like even for like question answering, captioning tasks, which these ones are fairly good at. So if there are like different musicians playing certain instrument, and then there is also an audio, if we ask what is happening in the visual scene, can you explain the captioning task, as we more classically say, these models are generally good at that. So definitely there are attention or shared attention layers where we do a self attention, cross attention, this sort of thing, to put it simply, and then try to make the model reason across the different modalities. But I think where the main problem is, the the initial barrier, or the initial high level understanding is there. But when it comes to, maybe as you said, so the example, it requires us to not only reason over the entire context, but also to understand that specific text which is written maybe at a tiny corner somewhere, to understand that okay, there it might be misleading. I need to verify this information, this cat, whatever is written, with the overall context of the image. So does the feature of the animal, so the ears, face, everything, does it correspond to cat or does it correspond to dog? So the reliance, as we see in most cases of these models, are on the textual modality. It's totally understandable, because text is the most the most I would say available form of data that we have. So a lot of these models are heavily trained on textual data, and
Yeah.
getting annotations is also relatively easier. I'm not talking about maybe like languages which are low resource, definitely, but for English, which is heavily used across the world, and we have huge amount of label data. So for that, the models are generally biased towards focusing on those specific cases. They are biased towards focusing on the textual modality compared to like the vision, and even less for the audio. So although there are definitely concepts of, like, we are using attention, we are trying to make the model understand, reason across these things, but inherently there are a lot of bias. And also in the architectural data training mechanism, how we are doing everything contributes to these modes of failure, I would say. So we have to, yeah, figure out more like different or sophisticated ways where we definitely gain the basics from the most available modality, the textual modality, but also there are some ways to debias this setup. So if this is the case, if we see something like this in a visual scene, but you see a word cat, you should also learn how to cross verify with the other signals that you see. So if you see 90% of the signal which are matching with a dog, and then there is only 10% which says cat, you should learn like which one to prioritize.
Yeah.
So I think this is the area where
Kind
many
of
of the efforts are going.
self-reflection, I think it's called.
Yeah, exactly. Yeah.
Okay, that's great. Sanjoy, I have a question that is about,
Yeah.
being you a researcher and being in that field and doing that for a living. What do you think would be a true breakthrough in multimodal reasoning? What does it look like to you in, looking ahead, of course?
I think that's a super excellent question, and something that intrigues me a lot. I sometimes imagine like what would be the ideal scenario where we would like to be, where we would want to understand all these different input signals. Yes, I would say the first step. I It's difficult to like jump to maybe a final stage, but if we break it down in a step by step process, synchronizing all these modalities naturally and understanding to generalize to this context. For example, if I have shown you a video of it, like a very busy road in New York where people are like running around, like people are doing lots of different things, horns honking, people are like talking on phone, different things happening. That's a video that I train our model on. And then I take you to a very serene beach in say Hawaii, where things are not moving that much, people are only maybe few person coming here and there, people are enjoying their life. So this shift from one specific domain of data or sample to the other domain, and still able to understand and reason across this different completely different perspective of human I would say interaction, is something that I feel is it's going to be really important. Because no matter how much data we label, there will definitely be cases which is beyond something, or maybe something that comes up new. So every time, do we go back and train our model again from scratch, or do we make models which are adaptive to such changes? So if there are something new, or maybe, of course, so we talked about adversarial attacks, right? So the attackers might come up with something completely new, which the model has not been trained before. So how do we tackle that? So I think the key aspect that I personally care a lot, and in general feel the community is moving towards, or we should aim, is data efficient learning. Something which definitely data is an important part. If I, as a deep learning practitioner, if I say data is not important, that will be like complete nonsense. But yes, the overall idea is to make sure that with the whatever data we have and available with us, we should make systems which inherently has this understanding across these different modalities, like that can synchronize well, generalize well to new context, new causes. Like there can be different reason why people may be playing an instrument. He can be angry, he can be sad, he can be happy. So this background information, all these different things are something that I am very much looking forward to, in like injecting this causal reasoning. Active learning is another area which I feel overall the community is going forward to. So my ideal situation would be, we have models which are fairly generalizable to different cases, which are robust to such attacks, and which has very good sense of learning from the context. It's not like pattern matching. So if there is something happening, I know that next event will be something like that. Not depending on these biases. Actually, it's more like, naturally, do you understand as a human being, even if someone walks in, if even if we have not seen that person, depending on the information that we gather by talking to him or her for maybe 5 minutes, 10 minutes, we could gather a lot of different information. So we ideally would want our systems to gather this human level intelligence, which I know is not maybe doable in the next 1 or 2 years, but definitely that's the long overarching goal. And the other aspect I would say is, yeah, embodiment, as you said, that will be the ultimate, like the pinnacle of AI at some point, if we could have systems which are actually solving like tasks for us, doing tasks for us, like paying bills, and just go beyond these basic things. Maybe like a robot can do pay bills for you, but also if it could help you in dealing with some of your like difficult problems which require decision making, understanding, taking into consideration different aspects of life. I think that's the overall goal, but we are long, like
Very
far away
nice.
from that. Yeah. So
Well,
yeah.
I'm glad that you brought this up because, as you very likely know, there is a lot of I would say blah blah in the field. Unfortunately, because this is an amazing field.
Yeah.
I studied artificial intelligence more than 20 years ago, and then
Wow.
again at university. And we have seen. I didn't experience personally the first winter. I was not even born, but in the 2000s at university, uh, neural networks were bigger on paper than in an
Hmm.
algorithm because we didn't have the hardware for that.
Yes.
So we come from that type of school where things were, very ground to the ground, very solid and sound. And now the feeling that I personally have is that there is a lot of hype. A lot of people are promising the unpromisable. So it's weird. So my question to you, and probably is going to be the last, unfortunately, because I would like to keep this conversation
Yeah.
another 2 hours if I could. um, no, but it's like you are someone who is definitely dealing, at the cutting edge of AI capabilities, and you know the field. You do research in that field. So who better than you can answer this question? Can answer. My question is the following: what would you want people to understand about the current state of artificial intelligence? And when I say this, I want to give you another perspective, which is the perspective of, let's say, an adult, an old elderly, okay, and of course a kid. So to give you an idea of the time span in which we could be seeing or experiencing a breakthrough and a shift in technology. So what would you want people to understand about the current state of artificial intelligence without hype, hopefully?
Yeah, I think that's an excellent question. So, in a word, I would say we have to first understand that AI is powerful, but it's still at a very nascent stage. It's still brittle at this point. So, complete reliance on this at this point, in most cases, I would say, is not right there. But we are definitely getting there. We would definitely be there after a point. And I think there has been a lot of fear of people about AI taking their jobs and stuff, which I feel anything that like we have anything under the sun has its both pros and cons. It's a matter of how we want to use it, like to our benefit, to our disbenefit. That's up to us. So everything has the positive and the negative side. So that's something, as an AI practitioner, I feel the idea behind all the hard work that the people are putting in, they never want to people lose their job. It's always just to help people to get rid of some of the boring stuff that you would ideally not focus on, and instead focus on something more meaningful, more challenging. So that's the overall takeaway. I would say we are at a very interesting transition point at this point. So we are seeing models which are technically moving from like very easy pattern recognition, understanding kind of matching kind of model towards more like holistic understanding setup, where we are gradually getting there, be it healthcare, education, I don't know, like for social media content generator. I mean, AI has been a very integrating part of their work efforts in general, and much more beyond that. So, but I also want, like in general, our listeners or people to understand that the systems are like very much at a very early stage these days. All that we are doing, it's just a step towards the broader goal of developing this AGI, as we use the term more recently, like artificial general intelligence. And definitely that's the overall goal. I feel the excitement is very interesting, especially to see the journey. As you said, for you it might be even more fascinating because you have seen it from when it was just a concept in paper, and now it's actually being translated to model systems. And even on our phones we have detection models, everything we do a face detection, we click photos, it just says that okay, you have been to this national park or this is the place. So geolocalization, all these things are very interesting applications of AI. I feel the to be steady with the community in general, and people are trying to make good progress. They are trying to like put in a lot of effort in making our lives easy, and I also feel part of the journey. I'm very excited to contribute to this thing. And definitely the goal is to make sure that these models or this interest in general, these systems are robust to attacks. They are safe to use. There is no data privacy like issues related to that, and make sure that these models are in general intelligent. It's not just some specific patterns or questions or things that these models are catering to. Generally they have this understanding across all these different signals, inputs, modalities, by means of like grounding, reasoning, as you said, alignment. So that's the overall goal, I would say. And we are making slow progress, but hopefully should be in the next few years things will get much better. So
That's
yeah.
great, Sanjoy. Thank you so much for your contribution, of course, and
Yeah.
I wish you the best on your research. That is Sanjoy Chowdhury from University of Maryland, College Park. Of course, we're going to report some of the links that Sanjoy will share with us after this recording, and of course, they will be available on the official website, datascienceathome.com, in the show notes of this episode. Thank you so much, Sanjoy. Thanks for being with
Thank you
us.
so much. Yeah, thanks.